Hello students and welcome to Lesson 2 of Unit 4. In this lesson we are going to learn a strategy to help us solve two and multi-step equations. Our strategy is going to be called do, undo, and it is going to be the process of reversing the order of operations to solve equations. Our essential questions for today are 1. When I look at an algebraic expression, how do I know what I would do first if I knew what the variable was? And then second, how can I reverse the order of operations to undo an equation to isolate the variable? We are going to be making a lot of connections to what we've learned about expressions in Unit 3. So I want you to think and recall a few things. First, what is the order of operations? The order of operations is an agreed upon way to simplify expressions by simplifying first the grouping symbols, second the exponents, third multiplication and division, and remember that's from left to right, and last addition and subtraction from left to right. The other thing that I want you to think about is what type of expression we use the order of operations to solve. Well, when we use the order of operations to solve, we were always talking about solving numeric expressions. For instance, if we took an expression like this, 4 times the sum of 3 and 8, and we were actually to do this expression, we're not actually going to simplify it, but if we were going to do that expression, we would take the 3, add 8 to it first because it's in parentheses, and then after we simplify that parenthesis, we would multiply by 4. These would be the two steps to using the order of operations to solve this expression. Or if we had an expression like this, this still has a grouping symbol. A fraction bar is a grouping symbol. So if we were to do this expression, we would have to simplify the numerator first by taking the 10 and subtracting 7. After we subtracted 7, we would have to divide by -2. Now, many of you are in the habit of writing divide -2 this way. From now on, as part of our equations unit, I would like you to avoid using that divide symbol and use a fraction bar instead. And you will see in the next lesson why that is much more useful to us. So divide -2. If we were going to simplify this expression, these are the two steps we would have to take to do so. Sometimes simplifying expression can be more than two steps. For instance, in this example, we still have a grouping symbol, which is the fraction bar, but we also have two operations in the numerator that need simplified. So first we would take that 5 and multiply it by 2, 5 times 2. Afterwards, we would subtract the 8 from it, and last, we would divide by -2. These are the three steps we would take to simplify this expression. Now, that was how we used order of operations in the past. Today we are going to learn a new use for the order of operations. We are actually going to reverse the order of operations and that we would use to solve a numeric expression in order to show us how to solve an algebraic equation. Here are the steps we're going to be taking. First, our first step is to identify the algebraic expression in the equation. For this strategy to work, that algebraic expression can be only on one side of the equation. So you cannot have an algebraic expression on both sides, one on each side. We'll talk about in a few lessons what to do in that case. The second step we're going to do is to draw a blank do and undo chart. The third is to think about how we would simplify the algebraic expression if we did know the value of the variable. We will write these steps on the do side of the chart, just like we did with those last examples. And our fourth step to creating the do and undo chart is to write the inverse operations of the do side of your chart in reverse order to show how to undo an equation containing the variable. And I will show you what this looks like in a problem. So here we have an equation. We know it's an equation because it's saying that two amounts are equal. 10x minus 5 is equal to negative 55. This left side of the equation, which is where you are usually going to find the algebraic expression, this is our algebraic expression. So what we are going to do is we are going to take that algebraic expression and we are going to create a do and undo chart for it. So our first step was to identify that algebraic side. Our second step is to draw a blank do and undo chart. Our third step is to fill in the do side. So we don't know what x is, but if we did, what steps would we have to take to solve this expression? So if you think about, if we knew what x was, we would have to multiply that number by 10. And then after we figured that out, we'd have to subtract 5. Now, our last step is to fill in this undo side. We are going to fill in the undo side by reversing the order of operations that we just wrote and doing the inverse operations. So instead of going from top to bottom, we're going to go from bottom to top. So what's the inverse operation of subtracting 5? Well, the opposite of subtracting 5 is to add 5. And what's the opposite of multiplying 10? Well, the opposite of multiplying 10 is to divide by 10. So if we were actually going to take the two steps that it would take to solve this equation, we would have to add 5 to each side and then divide each side by 10. We're not going to solve them today. Our goal is to learn how to write this chart to show us the two steps here, 1 and 2, that we would need to take to solve it. Let's look at another example. We have 3 times x divided by 5 is equal to 12. First step, identify the algebraic side of the equation, which is this side because it contains the variable. So we are going to make a do and undo chart for this expression, 3 times x divided by 5. So our second step is to draw a blank do and undo chart. And our third step is to fill in the do side with what we would do if we did know what x was. Well, if we knew what x was, we'd have to multiply 3 first, because the fraction bar is a grouping symbol, which means we have to do everything in the numerator first. So we would take that x and multiply by 3, and after we multiply by 3, we'd have to divide by 5. Now to undo that, which is our fourth step, we're going to go in opposite order, doing the opposite operation, the inverse operation. So what's the opposite of dividing by 5? The opposite of dividing by 5 is to times by 5. And what's the opposite of timesing by 3? Dividing by 3. So here are the two steps we would have to take to solve this equation. We would have to multiply by 5 on each side and then divide by 3 on each side. Let's look at another example. First step, identify the algebraic side of the equation, which is here because it contains the variable. So we have 17x minus 10 as our algebraic expression. Now our second step is to draw our do and undo chart. Our third step is to fill in the do side with what we would do if we did know what x was. Well, if we knew what x was, we'd have to multiply by 17. And after we multiply that number by 17, we'd have to subtract 10 from it. Our last step is to fill in our undo side, which to do that, we have to do the reverse order and the inverse operation. So what's the opposite of subtracting 10? Adding 10. What's the opposite of timesing 17? dividing 17. So here are the two steps we would have to take to solve this equation. We would have to add 10 to each side and then divide each side by 17. Here's an equation: 8x divided by -4 is 36. So first, identify your algebraic expression, which is here on the left side again. Second step, draw our do and undo chart. Third step, fill in the do side. Well, if I knew what x was, I would first have to multiply it by 8, and then I'd have to take that amount and divide it by -4. Since I don't know what x is, I'm going to have to work in the opposite order, doing the inverse operations. The opposite of dividing by -4 is to multiply by -4. The opposite of multiplying by 8 is to divide by 8. So these are the two steps I would have to take in order to simplify this equation. I would have to multiply each side by -4 and then divide each side by 8. Let's look at a three-step equation. Here we again see the algebraic side, and we will write that as our first step. So we have 18 times x minus 4 divided by 2. Now, our next step is to draw our do and undo chart. If I knew what x was, I would first have to multiply it by 18. After I multiplied it by 18, I'd have to subtract 4 so that I would simplify the whole numerator, and last I would divide by 2. Now to undo that in an equation, I have to work in the reverse order, doing the opposite operation. So the opposite of dividing by 2 is to multiply by 2. The opposite of subtracting 2 is to add, the opposite of subtracting 4 is to add 4. And the opposite of timesing 18 is to divide 18. So these are the three steps I would need to take to simplify this equation. I would have to multiply each side by 2, then add 4 to each side, and then divide each side by 18. 3 steps to solve this three-step equation. Let's now summarize what we've learned. We've learned that to help you solve a two-step or multi-step equation that contains only one algebraic side, you can create a do and undo chart. The undo side of the chart will specifically tell you what inverse operations to use to solve the equation and in what order you need to use them.